Okay, so this one is I, complex number. Now, let me give you a little review on that. I is really the square root of minus 1. So if I have I squared, means if I have I times I, so like if I have square of minus 1 times square of minus 1, what is that equal to, anyone? It's kind of like I have radical A times radical A, you said is equal to A, right? So radical, your A is minus 1 here. So that would be just minus 1. That's plus 1. With each of these, so like A, radical A times radical A is equal to A. Your A happens to be minus 1. So every time you see I square, you can replace it with negative 1. This is something that you want to memorize it. I square is equal to negative 1. Now, what is I to the power of 3? I to the power of 3 would be I to the power of 2 times I. Okay? I to the power of 2 is negative 1 times I. So that would be negative I. So you get me so far? This is something you don't want to memorize it. As long as you know how to break it down, you can always get it to negative I. I to the power of 4 is worth memorizing, because really this is I squared times I squared. We already memorized I squared is equal to negative 1 times negative 1. That would be equal to positive 1. So that's a good one to memorize. I to the power of 4 is equal to positive 1. This would help me to simplify I to the power of any exponents, really. So I'm going to put a star next to this one. And the rest is pretty simple. I to the power of 5 would be I to the power of 4 times I. I to the power of 4 is already 1 times I, so that would be equal to I. So it's I to the power of 6. I to the power of 6 would be I to the power of 5 times I. Now I to the power of 5, we already figured is I times I is I squared. We already know I squared is equal to negative 1. Now look what's happening here. There's a pattern going on. It either would be plus or minus 1 or plus or minus I. And the pattern is pretty obvious here. So I to the power of 7 would be I to the power of 6 times I. I to the power of 6 is minus 1. And the other one is the negative, that would be I. That would be minus I. Guys, why don't you just talk? That would be a lot easier. Like I said, I cannot read all the chatting there while I'm lecturing. So some Sylvia says that events are negative. What do you mean by that? Sylvia, can you talk? What's the problem?
Hello? Hello?
Yes, please. What's your question?
Hi. No, I was just saying, like you say I to the 6, because usually that would be even, but it's odd here. Or I to the 5 is positive, but normally if you were doing something like that, it would be negative.
Okay, but it's not related to being even or odd in this case, because see, this is odd. I to the power of 3 is odd, right? It results into minus I when I do that. The next one is 5 is also odd, but it is also plus I. So just being odd doesn't mean it's going to be this is odd became negative I. This is odd became positive I. So this is even, it's plus 1. This is even, becomes negative 1. So it doesn't mean if it's being even or odd doesn't mean a whole lot in this case.
I see.
Understand what I'm
Okay.
trying to say? Okay. So, but there's a pattern going on from I to the power of 1 to I to the power of 2 to I to the power of 3 to I to the power of 4 and so on. The pattern is either will be the plus or minus 1 or plus or minus I. The pattern is start from -1, go to -I, and then go to +1, go to the I, and then the pattern starts from here again. See, we go to -1 again. So what was after -1? Was -I, right? So this turns to -I again. So the pattern is there. If you want to study the pattern, that's how you can do that. You can see the pattern go from here would be I to the power of 2, okay, and then when it goes to I to the power of 3, and then it goes to I to the power of 4. It's kind of so interesting to look at, even if you're not going to use it. Then there will be I to the power of 5. And then I to the power of 6, you see I to the power of 6 and I to the power of 2 go back to the same number again. That would be the pattern there. Then you go back to the I to the power of 6 again. And then you go to I to the power of 7, I to the power of 8, I to the power of 9. I'm going to stop right there because I have to go forever. But the pattern is this. If you have I to the power of 2 would be resulting to -1. If you have I to the power of 3, that results to -I. If you have I to the power of 4, it results to +1. If you have I to the power of 5, it results to I. So you either would be plus or minus I or plus or minus 1. But looking at the pattern, you see that the pattern exists here. When I'm at I to the power of 2 is equal to -1, and then I to the power of 3 will be minus. So the pattern is -1, -I, 1, I, and you go back to -1, -I, 1, I, and so on. So we see the pattern here going on. But you don't really have to don't care about the pattern. What you want to, the two things that you want to memorize on this would be these two, would be helpful. One is I squared. Everybody see what I squared, you just change it to -1. That would be very helpful when you simplify the expressions. And this would be knowing I to the power of 4 is equal to +1 would help me to evaluate the one that the high exponents. I'll show you what I mean by the next two examples. So if I multiply this by term by term, let's see what happens. So here I have in this case, well, this is an easy one. You just have to add them up. -5 plus 3i. So if I distribute this minus here, I get -4 minus 2i minus 12i. It's just simply adding like terms. So here we have all the numbers, all the i's. If I add all the i's together, I get 3 minus 2, that give me 1. 1 minus 12, that gives me -11i. Okay, and then if I add the constants together, I get -9. So the correct answer of this one would be this one. That's pretty simple.